one is, what do you mean by a process? Process is nothing but a program is in execution state. Okay, there are two different types of processes are presented. The first one is called as operating system process. The second one is called as user process. User process means the process which is created by the user or programmer. OS process means which is inbuilt in nature. Okay, so here process means take the input from the data and process the information. After process information, you have to get the output. That output will be given to the corresponding customer or corresponding user. Next one, what are the different states of a process? There are 5 different states are presented: new, ready, running, waiting, and terminated. New purposes create the new process. Ready purposes to identify which process is ready to occupy the processor. Running means uh, process is in execution state, then that will be called as a running state. Waiting means whenever the running process is having the interrupt or having the request of IO, automatically the corresponding process moves on to waiting state. So after successful completion, the process will be terminated. So these are the 5 different states of a process. Next, what is the difference between process and program? Program is called as a passive entity, process is called as active entity. Why we have to say passive and active? Passive means just you have to construct the different instructions. Okay, just you have to create the program, but you did not execute information. But what the program you are written, that written program will be moved into execution state, then that situation is called as the process. So here you have to create an instruction here and you have to execute the instructions here. So program is called as passive, process is called as a active entity. Next, what is a thread? A thread is called as a lightweight process, or a thread is a basic unit of CPU utilization. That means the thread which contains a thread ID, program counter, register state, and a stack. That means with the help of the thread, we can execute multiple operations parallelly and we have to get the data very quickly. Okay. Next one is, what are types of threads? So there are 2 different types of threads are there. The first one is user thread. Next one is kernel thread. So the thread which is created by the user, then that will be called as user thread. So in this diagram, we have to shown here, user thread means web server and databases. These are the threads which are created by the user. Kernel thread means the threads which are present inside the operating system. So with the help of this kernel thread, we can perform different kinds of operations which is present inside the OS. Okay. Next one is, what is a job queue? First of all, you have to know what is a queue. Queue means a set of instructions are present in one specific order, right? So job queue means when a process enters the system, it is placed in the job queue. For example, if you are in the ticket counter system, take the ticket counter system. So first of all, you have to be placed in the some queue order. Okay, so all these persons or all these passengers is called as a job queue. Next one is ready queue. Ready queue means which process is ready to occupy the processor or CPU, then that is called as a ready queue. For example, in previous case, job queue means all the persons are in one specific order. So whenever the ticket counter is open, so automatically all the persons are in ready. That means they are ready to take the ticket from the ticket counter, right? So this is the best example for ready queue. So job queue means a set of all processes to be stored in the job queue. Ready queue means which process is ready to occupy the CPU, those data will be stored into the ready queue. Next one is, what is the basic difference between preemptive and non-preemptive scheduling? Preemptive means if one process is in execution, after such amount of time, the other process is ready to join the CPU, then we have to check the priority between these two processes. Then we have to remove the current learning process and insert the new process inside the program. Then that is called as preemptive. Preemptive means in middle of the execution, we have to remove the current running processor and insert the new process for execution. In case of non-preemptive, if one process is entered into the execution, after successful completion only, you have to put the new process into the corresponding processor. That is the main difference between preemptive and non-preemptive. Preemptive means you have to remove the processor between the execution, but in case of non-preemptive, once the process entered into execution, after completion only, you have to remove the corresponding process data. So this is the best example. First process P1 is entered. After certain amount of time, process P2 is came, automatically process P2 is entered into the execution. Process P1 is waiting, process P2 in execution. After certain amount of time, process P2 is getting the error, that means interrupt. So the control goes to P1 and the process P2 in waiting state. This is called as preemptive. Non-preemptive means after successful completion only, you have to assign the process P2. So is non-preemptive scheduling frequent in a computer? Why? The answer is no. So non-preemptive scheduling is not frequently used in the computer. Why? Because it increases the ideal time. So first of all, you have to know one point here. The CPU should be in busy state. The CPU should not goes to ideal state. If the CPU goes to ideal state, then that system is not the best system. So compulsory the CPU should be in busy state. But in case of non-preemptive, the CPU moves on to ideal state and also reduces the overall performance of the system, and the process have to wait for longer amount of time. Why longer amount of time? If the process, first process P1, process P2, three process are there, P1, P2, P3. First of all, process P1 is inserted. So after that amount of time, process is having some problem. So automatically process P1 stop the operation. Is it possible to store the process P2? No. Why? Because the case is non-preemptive, means after successful completion only. After successful completion of process P1 only, process P2 is inserted. So that is the case of non-preemptive. It will take a long amount of time to insert into the corresponding processor. Next one is, what are the different CPU scheduling algorithms? So there are four scheduling algorithms are there. The first one is FCFS, first come first serve scheduling. It is a non-preemptive scheduling. SJF, shortest job first, it supports either preemptive case or non-preemptive case. Next one is priority scheduling. It supports either preemptive or non-preemptive scheduling. A round robin scheduling algorithm, this supports the pure preemptive scheduling concept. Okay. Next one is you have to know some fundamental or important definitions like throughput, turnaround time, waiting time, and response time. What is throughput? Throughput means number of processes that complete their execution per unit time. Okay, per unit time. For example, we are carrying some lab exams, right? So we are assigned some time for, within 3 hours you have to complete the all the tasks or all the programs, right? So for example, we have to take first 1 hour. So within 1 hour, 10 people are complete the programs, right? So automatically they will be moved from lab to some outer space, right? So throughput means how within the time limit, how many number of processes get completed the task, then that is called throughput. Turnaround time means how much amount of time to execute a particular process. That means we have to identify, for example, one student is having the highest having the good knowledge about the subject, some other persons is having a slow learner, that means he don't know the minimum basics of the concept. So if the person who's having the knowledge, he will execute a data within the 10 minutes or within 20 minutes, but who is the slow learner, he will take some 1 hour or 2 hours to execute the program, then that time is called as the turnaround time. Waiting time means how much amount of time a process has been waiting in the ready queue. That means if I take, if we are move on to the some ticket counter system, so you have to wait for whenever the counter is open, so you have to wait for that amount of time. Whenever the counter is open, automatically the turn goes to ready state. So waiting time is how much amount of time the process is in waiting state. Response time is the time at which the process gets responded. For example, I'm asking one question, so please tell me what is the process. So automatically the question reaches you within 2 to 3 seconds, right? So after 1 minute, you will give the answer. At what time you will respond my question, then that time is called as a response time. So these are the different terms of throughput, turnaround time, waiting time, and response time. Next one is, what is context switching? The name is called as switching. Switching means moving from one position to other position. So what the purpose of context switching means, transferring the control from one process to other process requires saving the state of the old process and loading the saved state of new process. This task is known as the context switching. So for example, process P1, process P2 is there. So at a time, two processes can enter into CPU? No, at a time, only one process will be entered into the CPU. So first of all, process P1 is inserted. After certain amount of time, process P1 requires some input operation. So automatically, process P1 moves on to the waiting state. Before waiting, process P1 should save the status. That means how much statements we are executed up to now. Okay, you have to save the status of a current processor and moves on to the process P2. Now process P1 moves on to waiting state. Now enter the process way. That means the control moves on to process P2. So process P2 will execute a data inside a CPU. After successful completion, the turn goes to which one? Process P1. Then where we have to start the work from P1 means previous what are the instructions they are executed. Then you have to skip the statements and move on to the next statements in the process P1. Now then this is called as a context switching. Next one is what is IPC? IPC full form is inter-process communication. So what is IPC means? IPC is a set of techniques for the exchange of data between multiple processes or threads. So with the help of inter-process communication, we have to send and receive the messages between different processes or different threads. So it allows the communication between various processes. For example, in this diagram, process P1, process P2 want to communicate with each other. So automatically with the help of IPC, we have to send and receive the messages between the process P1 and process P2. What are the various IPC mechanisms? Actually, there are 5 different mechanisms are there. The first one is sockets, second one is pipes, third one is shared memory, the fourth one is signals, and the fifth one is the message queues. So these are the different IPC mechanisms are existed. Next one is what is SMP? SMP full form is symmetric multi-processing. So the diagram which showcase the exact information. So multiple CPUs are there, multiple processors are there. These processors can perform different tasks depending upon situation. Now this is called as symmetric multi-processing. So it is the most common type of multiple processor system. In SMP, each processor, that means CPU, runs an identical copy of the operating system, and these copies communicate with one another when required. It means they have to communicate with each other depending upon the requirement. So this is the topic of symmetric multi-processing. Next one is what is critical section? So critical section, but it is a section of code which can be executed only by one process at a time. I want to give an example. In our class contains 60 students. In our class contains only one printer. I am asking that each and everyone should showcase me what the messages you are typed in your laptop. Just so you have to take the printout. So at a time, 60 students are given the request to printer. So all the 60 requests can be taken by the printer? No. Why? Because it is a single printer. It can accept only one request at a time. If 60 printers are there, then 60 students can get the printing option parallelly. But if you are having only one printer is there, then automatically you have to identify this one. It means critical section means I want to take the printout. So first of all, you have to check the condition. Which person is satisfied with the condition, then that person is entered into the critical section. Sir, is it possible to take the printout of 2 persons? No, it will not be possible. At a time, 2 persons cannot be active on the printer. Okay. So after performing the operation, you have to leave from the critical section. That is called exit section. Reminder section means how many number of people are waiting. So for example, 60 students are there. One person is taking the printout. Then how many students are remaining? 15 students are there. Those 15 student data stored in the reminder section. That means at a time only one process can perform the operation. So when the critical section occurs means shared resources, shared memory. That means whenever we are sharing any resources, we have to get the